Welcome back. In this session, I'm going to discuss the basics of context switching. So, what is context switching? Context switching, as the term suggests, when a process is executing and if there is single CPU and your operating system is multi-programmed or multitasking, like there are multiple processes initiated in the system, but single CPU is there. So, what will happen? If one process is executing and let's say an interrupt generated, or maybe the process is not able to utilize the CPU, it is waiting for IO, then the CPU control need to be switched from one process to another. But when this CPU control is switching from one process to another, it doesn't mean the previous process is going to be terminated. All the data, registers, buffers will be stored somewhere. You consider like PCB will be updated, right? And that PCB will be shifted somewhere. It will be loaded somewhere in the memory or maybe secondary memory, and then the new process will be loaded. So these particular process considered as the context switching. The steps I have already written here. So when the context switching will happen, the very first thing, the current process context will be saved, right? So the context of the current process means saving the values of registers like program counter or instruction register, like all these values will be saved, and the PCB of the current process will be updated. Then the PCB of the current process will be switched to a queue. There are different types of queues in the system, like ready queue, new queue, or IO queue or job queue. So the PCB will be added in one of these queues, and then once the current process has been added in a queue, the new process context will be loaded. And who will select this new process? Actually, this new process which need to be executed next will be selected by a scheduler, right? Scheduler is an intelligent module which decides the CPU control need to be switched to which particular process next, right? So after the loading of the context means again the program counter value and the other specific register value will be loaded in the memory. Then the data structure of the system will be updated, like PCB will be updated so that the current process state, if you are going to change for any of the process, its PCB obviously will be updating, right? And then the CPU control can be switched from previous to this newly loaded process, and the relevant memory will also be updated in the system. So all these steps will be consecutively performed whenever the context switching will be performed in any of the system, right? So this is sufficient for this session. Thank you everyone for connecting. See you in the next session.